Hello everyone, my name is Ralf Müller. I'm a product marketing manager for the software and informatics division at Agilent. And with this presentation, we will introduce the new product ADFExport for OpenLab, which is planned for release in June. And I additionally will show an approach towards a whole product for generating of an ADF file to reading the ADF content back via the Elsie data viewer. For this, we will have a demo prepared. We are splitting this presentation into 3 parts. So you can take the next slide, please.
Mm-hmm.
I will give an overview what Agilent wants to achieve with Allotrope, also in combination with the APN, the Allotrope partner network, what we did in the past, and what is our vision for the near future. Henrike, our product owner for the Agilent Allotrope products, will then focus on our new release of ADFExport for OpenLab. And Heiko will give a demo about the Elsie data viewer, showing an example how data can be retrieved and demonstrated in an easy way, making use out of the Adf High-Level Api. So if we look into labs today, how can ADF help? How can labs add value to their workflows, and how can they generate return on investment short term? If you look into labs, and this means not only pharma labs, there are major pain points. So how can I store my data safely, retrievable, and even ad hoc usable or accessible over many years or even decades? There is no satisfying answer today, and often a tedious search has to be started. And in many cases, we know analyses have to be reworked from scratch, and this means a lot of costs in time and lab resources. So the reuse of data is not an easy task today in laboratories, and it's needed most. Also, the exchange of data internally from one lab to another lab, or the external exchange of data to contractors, which is very common in the pharmaceutical field, especially with contract manufacturers, is hard to do, and the transfer of protocols needs approval to ensure correctness and validity of the data. So if you look in an ideal lab world, we could follow an end-to-end workflow, enriching data from unit operation to unit operation. You can see this in these blue boxes with the enrichment in the purple ones. And consolidating all information into one secure file for long-term archiving, for easy finding, and for reusing. And this is what we want to achieve with Allotrope. And for this, we are engaged since 2014. The next, please. In the beginning, we did prototype development in collaboration with Allotrope members. And by doing this, we learned a lot and helped improving the Allotrope framework. In 2018, we commercialized the first Agilent Allotrope product with the ADFExport for ChemStation. And in 2019, we complemented on ADFExport for OpenLab CDS. This new release will combine the 2 Agilent CDSs into one package and extend the data description part. Next, please. Here you can see a vision we have for OpenLab, and the question is what will be next at Agilent. We are accomplishing the ADFExport, which you can see depicted here in the first part with the new release. For the next release, we are planning to access the OpenLab ECM for long-term storage and archiving capabilities. The semantic layer you can see in the most right block. Then we will need a smart data lake connection or triple storage, in which we inject the semantic content of the generated ADF files by our CDS systems for dashboarding of different information, as for example instrument utilization or column usage or general trending analysis. For this part, we can imagine to work closely with the Allotrope members, but also to partnering with the APNs, the Allotrope Partner Network. And now I will hand over to Henrike. She will give insight into the new release, ADFExport for OpenLab.
Yeah, thank you, Ralph. So I would like now to present our upcoming ADFExport version and give you an overview about the functionality and the supported workflows within the Agilent data systems. So what's new in the version? A really big milestone we achieved is that we now store LCUV metadata in the data description of ADF. So the data structure is based on the data model, which was released by the Allotrope Foundation in March of this year. What's also new is the much more simplified deployment, which means there's one single product now available, including 2 add-ons, one add-on for ChemStation and one for OpenLab CDS. A third major feature is the improved performance of the ADF file generation. So we use a newer version of the Allotrope Framework, and we activate the audit trail at the end of the ADF file creation. Then we introduced some CDS-specific features. So for OpenLab CDS, it's now supported to export ChemStation data to ADF, which could be interesting in a migration scenario. And then we have some ChemStation-specific features to align with the add-on for OpenLab CDS. So also for ChemStation now, the distributed system is supported. We can export sequence data, and we can export the data not only to a local file directory, but also to a network share. And we could do file migration. As we just have seen, the Allotrope data format consists of 3 main data containers. So we have the data description, the semantic model, and here we now store metadata, for example, about the HPLC system, including the column information. We have information about the sample, who submitted the sample, and results like details. Then in the data cubes, we store the raw data, so chromatograms and spectra. And then we have the data package, the virtual file system, which we use to store the original CDS files, either from CDS or from ChemStation. Here you can see our expanded compatibility. And so we now support 2 ChemStation versions, CO109 and CO110. And for OpenLabs, we support 2.4 and the new version 2.5. What I also would like to highlight, that's possible to export legacy data. So you can export existing data acquired with ChemStation CO101 or later, or OpenLab CDS 2.0 or later. Now we come to the different workflows. For ChemStation, there's a command line tool available, which you can use to export existing ChemStation data to ADF without having to reload the data into the ChemStation. And what I already mentioned, you have the possibility to migrate existing ADF files created with an older ADFExport version. So yeah, you could use an ADF file as input parameter. Additionally, you can export your data automatically to ADF. This can be either done by using a post-run or a post-sequence macro. In the first example you see here, this is done by post-run macro on a run-by-run basis. And in the second example, the export is done sequence-based. In OpenLab CDS, you have the possibility to export your data manually to ADF. So typically you acquire your data, review and analyze it in data analysis. And after saving all your results, you can export the data by using a ribbon command. In this case, one ADF file is created for the whole result set. This means that the whole sequence context is stored in one single ADF file. It's also possible, like in the ChemStation, to do an export automatically by defining a post-processing plugin in the processing method. What you see here in the first example is the unattended processing and acquisition, which means you can process the data already during acquisition without opening data analysis. You simply provide a processing method, including the ADFExport plugin, when setting up your single run or your sequence. And at the end of every injection, one ADF file is created. In the second scenario, can be that you acquire your data first and afterwards load your data in data analysis, review and process your data, and you get an ADF file, which you can use for archiving purposes. That is all from my side. So now I will hand over to Heiko.
So, Jamie, would you please provide me the presenter role? So, can you see my screen?
Not yet.
Oh, yeah. So now you should be able to see it.
Now we see it.
Yeah, okay. Hello, welcome. And I will provide you a short demo of the Elsie Data Viewer, which is using the Allotrope High-Level APIs. And we are reading CDS data that has been exported out of the ChemStation or the OpenLab CDS and view this. And then I will also show how you can make use of that Elsie Data Viewer with our OpenLab ECM products. First, some words about the Allotrope Lc High-Level API. So far, when there was just the Allotrope low-level ADF API available, and this required learning of the semantic web skills. And this is something not every developer could afford. And to lower this hurdle, Allotrope Foundation had since quite a while the idea to provide an Elsie high-level API to ease the reading of these Elsie ADFs. And Ben has done a great job to provide a version of that, and Agilent has contributed to this work as well. And so we made sure that all the content that is written by Agilent ADFExport can be read by this high-level API. And I wanted to mention that all this is common data, so common shared information. So this is nothing Agilent specific, and I will show that later in the demo. And if other vendors will also follow the Elsie ADF standard, they will also be able to read that information through this common API and also through that Elsie viewer I will show in a minute. At the bottom, you see a picture how this works. So on the left side, you see the Elsie ADF consumer, for instance, the ADF viewer. On the right side, you see the ADF file with the data description. That means the semantic web.
This is Matthew. Do we lose Heiko? I think we lost audio for Heiko.
One additional note: I see the Calgary hotel. I'm not sure.
Yeah, I just was telling him that, or was trying to tell him that. I just realized he wasn't showing his demo.
Okay.
Okay. So can you hear me now?
Yep, we hear you.
We can hear you.
Can hear you, but we can't see your slides. We just see your screensaver.
See the hotel background.
Oh, okay. So now, okay, I have to switch to another. Okay. I have two screens. Just a minute.
The new normal.
Yeah, so this has switched screens somehow while this was disconnected. Sorry. Okay.
We do see it now. Thanks, Heiko.
But you see it in the, not in the.
You see the PowerPoint, not the.
Yeah. Just a minute. Just a minute. Okay. I think you still see my PowerPoint, right?
Yes.
How do I? Okay, just a minute. So now you should be able to see it. Okay, good. Okay, now you should be able to see it, right?
So we see the PowerPoint presentation mode. Is that what you want?
Yeah.
Okay, then we're good.
Thank you. Sorry for that. So on the left side, we see the Elsie ADF consumer, which is the viewer, and the right side, the ADF with the data description, with the graph and raw data in the data cube. And on the upper right side, you see one example of a graph. And so that can be read through the ADF low-level API. And what's new is the Elsie ADF high-level API, which uses standardized Sparkle queries. So that means query to get the information out of the ADF for Elsie data. And the high-level API provides classes like for instruments and device information, injection, sample submitter, chromatograms, UV spectra, and peak details. And that is available for C# and for Java, and makes it easier for consumer to base software products on Elsie ADF. So that's a screenshot of the Elsie ADF viewer. I will go into the details a little bit later when I showed it in the demo. You can visualize the Elsie UV data for single samples and sequences. You can visualize all the information that is in the Elsie ADF, and you can read that information. It's a Windows 10 desktop app, and it can be linked to the ADF file extension as default app for the Windows operating system. So as soon as you click on an ADF, it automatically comes up. And we make use of this with our Agilent OpenLab ECM 3.x and ECM XT product. And I will show that in a video how this is done. And Agilent will license the source code of this application back to the Allotrope community, and it's intended to release a compiled version of that and make that as a download available from the Allotrope web page. But the source code can also be used to get an idea how you can use the high-level API. So we're working on contributing that to the Allotrope Foundation. Okay, that's all on the slides, and now we'll get into a demo. Let me just move the screen since so are you able to see a new background?
Yep.
Yeah, okay, great. So let me start the Elsie Adf Viewer. There are two modes. One is that you just start the application and then you select the ADF. And the other thing is that you click on the ADF and then it comes up with the loaded content. So here is the mode where I select the ADF, and let me just show you some example ADFs we have exported out of our OpenLab ChemStation or OpenLab CDS using our new ADFExport 1.2. So you can see here on the left side the analysis runtime. So as I said, you can visualize single sample or sequence information. Here's the single sample run name, and then you can see further information that has been entered during the acquisition. That means the sample name, the sample submitter from the system, or other username would be shown here, the acquisition method, the data processing method, the injection information. You can also see what kind of chromatograms are stored in the ADF. In this case, it's just 3 chromatograms from a VWD. There is no spectra available. On the right side, you see which kind of instrument has been used to acquire that information with the instrument name and detailed device, module, serial number, firmware information. In this case, it's a compact Elsie, and you can see also the column information. In this case, there is no peak table in peak details available, and there is here the chromatograms shown that are contained in the ADF. That is a basic, simple example. Let's go to the next step, loading another ADF, which has a little bit more content. Again, it's a single sample. You see the information here that describes the acquisition context. Here now we have an UV spectra acquired, and there's also peak table information available. So that's all common Allotrope defined terms. So there's nothing Agilent specific in there. So that would be available also for other ADFs when they follow the standard. And then you can see here the chromatogram visualized. And if you select here on the timeline certain points, the spectra get extracted out of the UV spectra information. So let's switch to another example, which has more information. Again, in a single sample run with chromatogram information, here you can see an Agilent Elsie with various modules and DADs, column compartment, autosampler pump with the module numbers, the serial numbers, the column information. You can see here a little bit more information about the peaks. So here is from DAD1A, 7 peaks available with all the information. And then you can see here the peaks visualized. And again, there is a possibility to select the timeline and then extract the chromatograms spectra out of that. So let me show how a sequence is visualized. It's again the same information, but the changes is that here the sequence option is selected, and you can read here the sequence name. Then in the box you can see the runs. So in this case, there are 3 different runs, and each time I select the run, the data is loaded into the UI. Again, you can see the context of the acquisition, the chromatogram, the spectra information, the device information, the peak table, and again, can extract the spectra out of it. So that's pretty similar to the single sample, but you select here the certain runs to visualize the content of each run. Okay, that's what I wanted to show you about the mode where you can select an ADF file. The other mode is when you link the ADF extension as default app with the Elsie Adf Viewer. I have put here an ADF on the desktop, and you can double click then on the ADF. Also works with the Windows Explorer, and then it brings up the ADF with the content that you have selected. And so I wanted to show you a short demo on how this works with our OpenLab ECM. Here is OpenLab ECM 3.x shown, but this works similar with our OpenLab ECM XT. I have here OpenLab CDS data that has been exported to ADF into ECM. And what you do to visualize that information, you navigate to the folder, double click on the ADF within the ECM client. It retrieves that information and then loads that information into the Elsie Adf Viewer. I have already shown that content before, so there is nothing to add here. And the same also works for ADF ChemStation. So that means you have to upload the exported ADF from ChemStation into ECM 3.x or XT, and then you can visualize that through the Elsie Adf Viewer by clicking on the file, and then this visualizes the content. Okay. So yeah, the rest is information I've already shown before, so you can see how this works. And so I want to stop this here since it's just the same information I've already visualized. Okay, and so we're back to the slide, and yeah. That was it from the Agilent perspective. We're open for questions if they can be asked already by now in these few minutes.
Yeah, while we're waiting for questions, and you can raise your hand or you can type something in the chat, and Jamie will unmute you. I just want to say, wow, fantastic. Heiko, Ralph, Henrike, I told everybody that this would be an exciting agenda, and so you've really kicked it off strongly. Appreciate that. And we look forward to getting access to that viewer. I think that's going to be a really useful tool in the ecosystem. So thank you.
All right, we have one hand raised. I'll mute Manuel.
Oh, hello. Yes, my name is Manuel, and I have one question. So far, I know the ADF Explorer, which always separates between the data description section, data cube, and data package. The viewer you were showing or presenting us does not really differentiate between these sections. Or did I just did not see it? Can you explain again, please?
Yeah, so it reads out the information from both worlds. So the metadata is read out from the data description, but the raw data you have seen in the UI is read from the data cube. So so that the lower part of the UI that comes directly from the data cube and uses the data cube API to read out the raw data, and the upper part of the screen is basically reading out information from the data description, and this data is read through Sparkle queries.
And data package section is not used in that case.
It's not yet visualized, but we can easily add this. So as I said, we will give this code to the community, and this can be further extended. So it's easily able to add this as well. But that's not yet in that version, but it shouldn't be a big thing to visualize that.
Okay, thank you. This was my question.
All right, I'll just ask, do we have time for one more question, or we have to move on to the next speaker?
If
Maybe,
there was
maybe
one more,
I'll
maybe
jump
we
in.
could answer it while we're transitioning. Yeah.
All right.
Yeah, maybe.
So
Can you hear me, Jamie?
yeah, you're not the person with the question though.
Okay, good. That's fine. Good.
So I'm unmuted. Sorry for pronouncing your name wrong. Chagir Izel from Bayer.
This is correct. Yeah, this is Jengir speaking from from Bayer Wuppertal. I would like to know, in the graphs we see the bottom of the screen, if we have the possibility to zoom out and to zoom in and to do some experiments there, because we are also checking from the regulatory point of view. So it would be very useful if we can see and zoom in to fulfill some regulatory requirements. Thank you.
Yeah. So it has some basic capabilities to zoom in, so that application uses basic Windows UI controls, no sophisticated scientific chart controls, but it's possible to do basic zoom in. But I don't know if that satisfies your need. So what we are planning to do from Agilent perspective is to also use this code base for an Agilent own viewer, where we have more capabilities to use our Agilent developed UI controls, which provides more sophisticated zoom in capabilities. And we plan to provide this at a later point in time with our ADFExport. So we plan to have a more sophisticated version provided by Agilent, and that can deliver more sophisticated UI controls.
Okay, thanks. Because the example you showed, it looked like it was static and you couldn't zoom anything. I've seen other examples from ADF which really was complicated, but here, for example, this looks like a static sheet. Therefore, was my question. But thank you.
Okay.
All right. Thanks, Heiko.